The interior of a modern passenger vehicle is engineered to provide the occupants with a comfortable environment by controlling the effects of vibration, temperature, and noise. To achieve this control, the materials and systems which comprise the passenger vehicle cabin must be able to withstand extreme environmental conditions. Plastic materials in particular are affected by temperature, humidity, and solar radiation. Product development engineers study the aging effects of these environmental factors on new plastic automotive parts and systems by exposing these products within environmental simulation chambers. One such chamber is called the Solar Climatic Chamber. The Solar Climatic Chamber controls three separate environmental parameters: solar radiation, temperature, and humidity. Each parameter can be independently controlled and cycled within the chamber specification. The most common solar climatic test methods are DIN 75220, MIL-STD-810, and IEC 600-68-2-5. A typical solar climatic test will expose the samples over a period of days by cycling between conditions of daylight and darkness, as well as dry desert-like conditions such as what you would experience in Arizona, and hot humid conditions as you would experience in Florida. Solar radiation is produced by the Metal Halide Global, or MHG, lighting system. The MHG radiation spectrum is one of the closest simulations of natural sunlight. Filters can be used to adjust the radiation spectrum to simulate either outdoor exposure or indoor exposure under window glass. The radiation intensity can be as high as 1200 watts per square meter and is measured using a radiometer placed adjacent to the parts being exposed. Exposing a plastic surface to solar radiation will cause the surface temperature to increase, so the surface temperature of the test sample can be significantly higher than surrounding ambient air. For this reason, in addition to measuring and controlling the ambient temperature, the solar climatic chamber can measure the temperature of the black standard sensor and/or the surface temperature of the samples. Varying the speed of the chamber's circulating fan can, to a certain degree, be used to control the black standard or surface temperature, independently of the level of radiation. Upon completion of a solar climatic exposure, the samples are evaluated for appearance changes such as color, gloss, or fading, dimensional changes, or functionality.